Hi, with this video we're going to look at RISAFoundation Interaction. RISAFoundation has the ability to transfer and loading information from both RISA-3D and RISAFloor. So this can be very useful in order to make your design process much quicker and cleaner because you're keeping all of your information contained in one model file. RISAFoundation transfers in these joint reactions from these two programs by way of load categories. This is not the same as load combinations, which can cause some confusion. So with this video, we're going to look at exactly what loads are being transferred over and how to confirm that you're getting the right loads carried into your RISAFoundation program. This first model I have open is just a RISA-3D model started here in RISA-3D. And we're going to take a look at it to confirm the different rules that are required in order to carry a RISA-3D model into RISAFoundation. The first rule is pretty simple. You just want to verify that your y-axis is your vertical axis. This is required to ensure that both the RISA-3D and RISAFoundation models have the same global axes and are referencing their coordinates in the same way. The second rule is back to the load cases, which is what I was just discussing. So chances are in your RISA-3D model, you have your load combinations, which you've made up based on BLCs, which are your basic load cases. Now if you applied any loads using our automatic load generators, such as the wind load generator or the seismic load generator, the loads are going to automatically populate into this spreadsheet and the categories are going to automatically be filled out. But if you had manually added any loads to your model, the categories will not be automatically filled out for you. So it's important that you remember to come in here and assign categories before solving. This will ensure that these loads get carried into RISAFoundation. Because the loads are carried over by way of load category as opposed to load combination, only the loads that have a category assigned to them are going to come through. If you have a model that has some loads that are assigned a category and some loads that are not, only the loads with the categories assigned are going to carry into your RISAFoundation program. Once I have assigned those all, I can go ahead and close this spreadsheet and solve. And notice I'm just solving one single load combination. In order to carry the loads into RISAFoundation, it's not necessary to run a batch or an envelope solution of all the combinations. Again, that's because we're not carrying over the loads based on load combinations, but rather as the unfactored load cases. So as we go into RISAFoundation using the director tool, we can see that all the load magnitudes are shown here. By default, the loads associated with the dead load category are going to show up first. But we can always open up our load categories spreadsheet to confirm that the other load categories came across. And as you'll see, all the loads are grouped here within their associated category, and you can click on any of these numbers at any time to verify the exact load magnitude that's applied to each node in what direction in order to confirm your loads. Again, these are the unfactored loads, so they're not going to be factored by any of the combination factors that you had in RISA-3D. And this is done on purpose so that you can rebuild your load combinations in RISAFoundation using the LC generator that are appropriate for your foundation design without having to worry about doubling up the factor multipliers. Excuse me. Once that's done, you can go ahead and build in your RISAFoundation model underneath these loads and point locations, and then solve for your design and analysis. Now I'll go ahead and close out of here, and next we can look at how RISAFloor interacts with RISAFoundation. So I'll open up my test-to-floor model next, and we'll take a look at that. This might be a familiar model to some of you, and I just stole it from our user's guide tutorials. It's just that simple model that we build in our user's guide. But I thought it was a good model because it shows a good combination of lateral elements, those are shown in red, and gravity elements, which are shown in the navy blue here. Now the same basic rules apply in order to get RISAFloor elements into RISAFoundation. You must have the y-axis as your vertical and you must assign load categories. However, because of the nature of RISAFloor, most of this is automated for you, so you don't have to do much to set this up. It's going to be done for you just based on the 2D view of the program. So as you can see from our global axes here, already the y-axis is our vertical axis. It's a little hard to see there, but if we take it into ISO view, you can confirm that. And then in load combinations, we could also, not load combinations, but any of our loading spreadsheets, look at area loads, you can see that all the load is automatically applied into a load category. That's just how the spreadsheets are set up to apply load. So you're entering in your magnitude into the live load or the dead load columns here, and those are going to be how the loads are applied to the model. So since those categories are already automatically set up for you, you can go ahead and just solve in order to carry the model into RISA-3D and then once again into Foundation. And once you get in there, you will be able to see all of your loading. Many times we're asked if both the gravity and the lateral loads are carried into RISAFoundation, and indeed they are. Because only the lateral elements go through to RISA-3D, it can be a little confusing because you don't see those gravity elements on the RISA-3D model, but once you take the whole thing into RISAFoundation, they will show up again. So just to keep that in mind, we can go ahead and verify it here. If we just take a look at grid line 1, for example, we'll see we have 1 lateral column and 2 gravity. So we'll just keep that in mind as we make our way through to RISAFoundation when we want to confirm our loading. So we'll go ahead and just solve this. And I'll go through all the different solution steps here that we're used to seeing in RISAFloor. And then once that's complete, we'll go ahead and take the model into RISA-3D, solve it there, and then finally into RISAFoundation to confirm our loading layout and our reaction loads. Once that's complete, we'll use the director tool to go to RISA-3D first. It's the intermediate step. Here we're just looking at the lateral elements, but again, all the gravity element information is carried through, and we'll see that once we get into RISAFoundation. So we'll just open up load combinations and just solve the first one to keep it quick. Finally, we'll go to the director tool and go into RISAFoundation. And once we're here, we can confirm that all of our loads, gravity and lateral, have come through. So just to confirm that, let's look again at grid line 1, and we can see we have loads here at 3 locations. If you want to look at it a little bit closer, we can see that at grid location F1, we do have a node here called R3D and 19. So that confirms that this loading was the lateral loading that came from the solution from RISA-3D. And then at D and E, we have nodes called floor _ 1 and 5 and floor _ 1 and 4. And those confirm to be just the gravity loads that carried over from your RISAFloor model. Again, you can take a look at the load category spreadsheet here and confirm any of the loads that carried through, gravity or lateral. And once you've done that and feel comfortable with your loading, you can go ahead and build in your RISAFoundation model and again solve for your design and analysis.